For the triangle inequality theorem, we have two cases. Case 1, the sum of the lengths of any two sides of a triangle is greater than the lengths of the third side. Let's have an example. In a triangle AIM, we have the sides. Let's name the three sides. We have segment AI, segment IM, and segment MA. In case 1, if we add any of the two sides of the triangle, it should be greater than to the third side. So let's try. If we add AI plus segment IM, it should be greater than to the third side, which is segment MA. Let's substitute the value. The segment AI measures 12 plus the measure of IM, which is 13. It should be greater than the measure of segment MA, which is 11. 12 plus 13, that will be equal to 25, greater than to 11. Let's try another. If we add segment IM plus segment MA, so those are the two sides of the triangle, it should be greater than to the third side, which is segment AI. Let's substitute. The value of IM is 3 plus the measure of segment MA is 11, should be greater than to the segment AI, to the measure of segment AI, which is 12. Let's get the sum. 13 plus 11, so it should be 24. It is greater than the measure of third side, which is 11. Let's try the last combination for the triangle. Let's see if this is correct in all forms. So if we add the segment AI, the measure of segment AI, plus the measure of segment MA, should be greater than the measure of segment IM. The measure of segment AI is 12, plus the measure of segment MA is 11, should be greater than the measure of segment MI or IM rather, that is 13. Let's get the sum. 12 and 11, we have 23. It is greater than to 13. So, meaning to say, in order for us to form a triangle, the sum of any two lengths of the triangle should always greater than the measure of the third side. Identify if the following set could be the lengths of the third side or the lengths of the side of the triangle. So we have 8, 5, and 6. So again, we should add any two and it should be greater than to the third side. So first one, we have 8 plus 5 should be greater than to the third side, which is 6. 8 plus 5, that will be equal to 13, greater than to 6. And this is true. Another, if we add 5 and 6, it should be greater than to the third side, which is 8. 5 plus 6, that is equal to 11, greater than to 8, that is true. Another combination, if we add 8 and 6, it should be greater than to the third side, which is 5. 8 plus 6, that is equal to 14, greater than to 5. That is true. Another simple step in order for us to determine if the three measure can form a length of the triangle, we just need to identify what will be the largest measure or the longest side. Here in our example, the largest measure or the longest side measures 8. So that will be our third side. Now, if the sum of the two other, which is 5 and 6, greater than to the longest side, it is always form a triangle. So 5 plus 6, that will be 11, greater than to 8. So we just need one true statement in order for us to form a triangle. We have 3, 13, and 10. Let's identify the longest side. The longest side is 13. Then we add the two remaining side, which is 3 plus 10. It should be greater than to the longest side, which is 13. 3 plus 10, that will be equal to 13. Greater than to 13, that is a false statement. Therefore, 3, 13, and 10 cannot form a triangle. Let's check. Suppose this segment measures 13. If we have two sides, for example, this is value of 3 and this is equal to 10. So 3 plus 13, we cannot form a triangle because this is equal to the longest side. So we cannot form a triangle. Another, if this is less than, for example, we have 1, 9, 6. So again, get the third side or the longest side, which is 9. And then add the two remaining measure, 1 and 6, should be greater than to the longest side. 1 plus 6, 7, greater than to 9. This is false. So we cannot form a triangle given measures 1, 9, and 6. How? If this is measure 9 and this is 1 and this is 6. So we cannot form a triangle because if we add the two shorter side, it cannot form a triangle. Let's try another. We have 8, 12, 12. So the longest side is the one of the 12 measure. One of the measure which have 12. Now add the two remaining. 8 plus 12 should be greater than to 12. 8 plus 12, that is equal to 20, greater than to 12. This is a true statement, therefore it can form a triangle. What kind of triangle? We have two equal measure of the side. It is said to be isosceles triangle. Another example, find the range of the values for the possible length of the third side of the triangle. List all the integral values of the third side. So unknown value, let's name the third side as x. So to get the measure of the x should be greater than to the difference of the two given measure, which is 12 and 8. So 12 minus 8. But it should be less than to the sum of given measure, which is 8 plus 12. So again, the third side should be greater than the difference of the two given measure, but it should be less than to the sum of the two given measure. So 12 minus 8, so we have 4, less than, x less than 8 plus 12, that will be equal to 20. So that will be the range of the value of the third side. Let's list all the integral values of the third side. So it should be between 4 and 20. So we have 5, 6, 7, 8, and so on until 90. So we do not have 20 because if the value of x become 20, it cannot form a triangle. What is the smallest integral value of the third side if the measure of the two sides are 5 and 8? Let's go back to our example. The smallest measure here is 5 and the largest measure here is 9. How do we get 5? We subtract the two given measure, and that will be t4 less than 2x, meaning the value of x is equal to 5. To get the smallest measure, and this will be the longest measure or largest side or the longest side. So here, to get the smallest integral value, we just need to get the difference of 8 and 5. So 8 minus 5 should be less than 2, the third side, which is x. 8 minus 5 is 3, less than x. So what will be the integral value of 3 less than x, or what will be the value of x? That will be equal to 4. So to make a statement true for this 3 less than x, the value of x should be equal to 4. We're talking about integral value or integer. Let's have one example, or last example rather. Find the possible values of x in the figure below. So again, our third side will be a side with unknown value. We have x plus 1 should be greater than 2, the difference of two given measure, which is 9 minus 4. But it should be less than 2, the sum of the two given measure, which is 9 plus 5. So we have 9 minus 4. Let's simplify the inequality. 9 minus 4, that will be equal to 5 less than x plus 1. Then we have 9 plus 5, that will be equal to 14. So the possible value will be, we have 5 less than x plus 1, and we have x plus 1 less than 14. Now let's have the operation. To simplify, we have plus 1. We need to transpose 5 minus 1 less than x. 5 minus 1 is 4 less than x. Next, we have x plus 1. Transpose. We have x less than 14 minus 1. So we have x less than 13. So the range for the values of x should be 4 less than x less than 13. So those are the possible values of x. So the possible values of x should be less than to 4, greater than to 4 rather, but less than to 13. Or 4 less than x less than 13. That is the triangle inequality.